Okay, now let's take this a little further with differentiation and trigonometric substitution. So in this case, usually we're faced with something which is an inverse of a trig function, and we have to differentiate. So for example, we have sine minus 1x. This is not the same as 1 over sine x. 1 over sine x is written as sine x to the minus 1. So this is sine inverse x. And sometimes it's called arc sine x. And theta equals arc sine x, sometimes described as that. For example, sine of 30 degrees is a half. Inverse sine a half is 30 degrees. Now the formulas involved in trigonometric substitution, usually we're looking at something which is sine inverse or cos inverse or tan inverse or cot inverse or cosec inverse or sec inverse. And what we try to do is whatever's in the bracket next to the sine inverse, we try to make into the sine. So we get sine x plus x, cos x equals x, tan x equals x, cot x equals x, cosec x equals x, and sec x equals x. So we try to make the thing in the bracket equal a sine x, so that we're left with something, a trig function, that we can differentiate easily. Okay, let's have a look at some double angle formulae that we need to memorize, and these are used when we do trigonometric substitution in differentiation and also in integration. The first one, very important one, sine 2 theta equals 2 sine theta cos theta, and this also equals 2 tan theta over 1 plus tan squared theta. The next one, very important, cos 2 theta, and this equals cos squared theta minus sine squared theta, and this equals 2 cos squared theta minus 1. This equals 1 minus 2 sine squared theta, and also 1 minus tan squared theta all over 1 plus tan squared theta. This leads us on to tan 2 theta is equal to 2 tan theta over 1 minus tan square theta. Cot 2 theta is equal to cot squared theta minus 1 over 2 cot theta. And then there are various ones we can derive. Let's have a look at some of them from these formulae. For example, from sine squared theta and cos 2 theta, which is over here. So if we take that to the other side, we get sine squared theta is 1 minus cos 2 theta over 2. And then similarly, cos squared theta equals 1 plus cos 2 theta over 2. Similarly, we can derive, let's have a look at a derivation for 1 minus cos x. So from cos squared theta, 1 minus cos 2 theta equals 2 sine squared theta. So 1 minus cos x, replacing the theta with x, over 2, that equals 2 sine squared x over 2. So 1 minus cos x is equal to 2 sine squared x over 2. So there should be a 2 there, cos 2, and then these two cancel. So 1 minus cos 2 x over 2, we're dividing the theta by 2. So this is an important formula. And also, let's have a look at 1 plus sine x. The 1 plus sine x, 1 is equal to cos squared x over 2 plus sine squared x over 2. And the sine x is equal to 2 sine x over 2 plus cos x over 2. So when we have 1 plus sine x over 2, we get cos x over 2 plus sine x over 2 all squared. And that is 1 plus sine x. An important part of knowing when to use trigonometric substitution is recognition of when we can use it. So where a is a constant in a formula and x is the variable, if we have something that looks like a squared plus x squared, we can substitute x with a tan theta or a cos theta. Where we have something like a squared minus x squared, we can substitute x with a sine theta or a cos theta. Where we have x squared minus a squared, we can substitute with a sec theta or a cosec theta. Which one we use depends on whether the inverse before the bracket is a sine, a cosine, or whatever. So if it's a sine, we're looking to make, if it's an inverse sine, we're looking to make the x into a sine. So if it was a squared minus x squared, we'd use this one. If it was a squared plus x squared, we usually use tan, so we'd make it into a tan. Some other formulae which are useful, or when we want to substitute a square root, a plus x, a minus x, or a minus x all over a plus x, and in this case x equals a cos a, and where we have a squared minus x squared over a squared plus x squared, or a squared plus x squared over a squared minus x squared. This x equals a squared cos squared theta, cos squared a, sorry, theta. There we go. For example, in this case we can have a minus a cos theta over a plus a cos theta, and this would equal the square root of 1 minus cos theta over 1 plus cos theta. And then all we do is we replace the 1 minus cos theta and the 1 plus cos theta with the derived formulae that we have, and we get square root of 2 sine squared theta over 2 cos squared theta over 2, and that equals tan theta over 2. Differentiation formulas that we need to memorize when we're dealing with inverse sine, d by dx, inverse sine x equals 1 over 1 minus x squared, d by dx cos, inverse cos x, minus 1 minus x squared, d by dx inverse tan, 1 plus x squared, and d by dx cot inverse cot x is minus 1 over 1 plus x squared. Okay, now let's go through some examples where we use differentiation by trigonometric substitution. Y equals inverse sine 2x over 1 plus x squared. Okay, the first thing we need to do is decide what this x is going to be. So from 1 plus x squared, as we did previously, usually we use tangent, a plus x squared, x equals a tan theta. So x equals tan theta, and theta equals inverse tan x. Now we do the substitution. Inverse sine. So the x becomes 2 tan theta over 1 plus tan theta. This is inverse sine 2 tan theta over 1 plus tan theta from our double angle formula we know is sine 2 theta, which equals, now we have the inverse sine and the sine, so they cancel each other out and we're left with 2 theta. So when we differentiate 2 theta, we're differentiating 2 theta is tan inverse tan x, so dy by dx is 2 and inverse tan 1 plus x squared. And that is your answer. At another example, y is inverse sine 2x square root of 1 minus x squared. So when we look at this part, we want to make it into a sine to make our differentiation simpler. So looking at 1 minus x squared from our previous rules, we know we can have that as a sine x equals a sine theta. So we have x equals a sine theta, where a is 1, so x equals sine theta, theta is sine minus 1 x. Now we do the substitution. Y equals inverse sine. So the x becomes sine theta, 2 sine theta, and we have the square root 1 minus, and the x is sine squared theta. So inverse sine 2 sine theta. We know that, let's have an aside here, we know that 1 minus sine theta is equal to square root of 1 minus sine squared theta is equal to the square root of cos squared theta. Therefore 1 minus sine squared theta is equal to cos theta. So this becomes 2 sine theta cos theta, inverse sine 2 sine theta cos theta from our double angle formula is sine 2 theta, These two cancel each other out, so we're left with 2 theta. Theta we know is inverse sine of x, so y equals 2 inverse sine x. So dy by dx of 2 inverse sine x, 2 1 over square root 1 minus x squared, or 2. And that is your answer. Okay, let's have a go at another example. Y equals inverse cosine 2x squared minus 1. In this case we let x equals cos theta and theta equals cos minus 1 inverse cos x. Substituting, y equals inverse cos 2, so the x is cos theta and it's squared minus 1. This becomes inverse cos. Now 2 cos squared theta minus 1 is the same as cos 2 theta from our double angle formulae. These two cancel. So y equals 2 inverse cos and 2x. So therefore dy dx, 2 down, and differentiate inverse cos minus 1 square root 1 minus x squared. And that is your answer. We're going to have a look at some differentiation and by simplification. So if y equals sine x over 2 plus cos x over 2 all squared, and we're asked to find dy by dx at pi over 6. Now if we look at this and we consider this as a and this as b, so it's a plus b all squared. So a plus b squared equals a squared plus b squared plus 2ab. So when we rearrange that, we get y equals sine squared x over 2 plus cos squared x over 2 plus 2 sine x over 2 multiplied by cos x over 2. So AB becomes a squared plus b squared plus 2ab. Now looking at this, once we've simplified it. This is nothing but 1, and this is 2, oh sorry, sine 2 theta. So sine 2 theta equals 2 sine theta cos theta. So theta in this case is x over 2. So this becomes y equals 1 plus sine 2 x over 2. The 2's cancel each other out. So it's 1 plus sine x. dy by dx, d by dx, 1 plus sine x, which is, when we do the derivative of 1 we're left with 0, derivative of sine x cos x, so dy by dx at pi over 6 equals cosine pi over 6, and that is equal to, pi over 6 is 30 degrees, and that is square root of 3 over 2, and that is your answer. Okay, let's have another look at simplification. Dy by dx, if y equals tan inverse 1 minus cos x over sin x. Now we're already given this in the form of cos x over sin x, so we don't need to do any substitution. So what we do is simplify if we can. Y equals tan inverse. So 1 minus cos x becomes 2 sine squared x over 2 over 2 sine x over 2 cos x over 2. We've done these before when we did the double angle formula, derivation of those, so if you want to look back at that. So this equals tan minus 1, these two's cancel, and this sine cancels with this, so leaving that as one sine, so that's sine x over 2, and this leaves us with cos x over 2. Okay, now y equals inverse tan, sine over cos is tan x over 2, so y equals, these two cancel, x over 2, and when we differentiate that, dy by dx, x differentiates to 1 and the half remains, so the answer is a half, and that is the answer. Okay, let's have another look at simplification. y equals tan inverse 1 minus cos x over 1 plus cos x. Okay, so simplification. We get inverse tan. 1 minus cos x is nothing but 2 sine squared x over 2, and 1 plus cos x is 2 cos squared x over 2. Now we cancel, the 2's cancel. This x over 2 is an angle, so we can't cross out the 2's to be left with sine squared over cos squared. So it remains as sine squared x over 2 over cos squared x over 2. So this becomes tan minus 1 sine squared x over 2 over cos squared x over 2 is tan squared x over 2. When we take the square root of tan squared, so this becomes inverse tan x over 2. So dy by dx, tan inverse and the tan cancel each other out, and we're left with x over 2, which again is a half.